Looks like we've got a pretty sparse class, probably because it's pretty and it's Friday out. So for those of you guys that didn't hear the first announcement, if you guys are using laptops, please move to the back. Otherwise, laptops shut. Also, if you guys need to leave early, please move to the back in the aisles. Super distracting if you guys leave early in the middle of class. Okay, so we're going to be continuing what we were going over on Wednesday about with different slides, and then we're also going to start going over header files versus source files. And finally, one of my favorite subjects, which I'm sure will be your least favorite subject, pointers. So, if you guys follow the joke here, that's what a pointer looks like if you represent it in hex. That's 3 of them. So before we get started on this, let's take a look at a class in Python. We'll start here so that we can backtrack a little bit. So in Python, we start a class with the keyword class, and then the name of the class, followed by all of the class's methods. Now in Python, classes for the most part just have methods. You don't really define data within a class. The data just kind of gets at runtime attached to a class. But we've got this special function that we're starting this class with, underscore, underscore, init, underscore, underscore. And if you remember back from the class's lectures way back when, that's a special function that gets called every single time you create or instantiate one of these classes. Remember, the class is the blueprint, and then once you instantiate it, you construct one, you've actually got a real house. You can actually do stuff with it. You can make as many as you want. So every single time you create one of those houses, this little chunk of code right here is going to get called. Everything that's indented. And if we read through this, all we're doing is setting some properties within this class. We're setting this class's name, which I just arbitrarily chose these names. I could have used my name or whatever I wanted. And we're setting it equal to what was passed into us. We're doing that for how much sleep the student got, how big the student's hangover is, and finally we're just going to print out that this student was created. So every time this init function gets called, it's going to print out the name and then is alive. Pretty basic stuff here. And then we've got one method in here called fight. And fight is a member method. So you're going to invoke fight on an existing object. So you're already going to have a student to call fight to begin with. Then the fight function, the fight method, is going to take in another student. And they're going to battle it out, see who wins. It's a pretty simple math function here. It's just how much sleep the student got to the power of the negative of the hangover. So the more sleep you got, the better. The greater your hangover, the worse. Yep? Yeah, we did go over dot notation quite a while ago, but I'll recap on it really quick. Self represents an object. Think of self as, it's an object instance. So it is itself a house, and once you have the house, you can access pieces within it. So say self.name is one of the rooms. You can go access one of the rooms, and in that room we're storing a string, the name of the student. That's the dot notation. So you've got an object instance and you're accessing something within it that is named. Either name, sleep, hangover, etc. And then the rest of this function just compares those two ratings and then prints out the winner and then returns the winner. Either the object that fight was invoked on or the other person. Now in Python, of course, we could just write code right here, start typing right here and use this. Because it's Python, you can just type code anywhere and it gets run in line. I'm going to pretend like it's C++ and make a little main class, a little main file. There's no function here, just pretend that this is your main function like it is in C++. So this is how you use a class in Python, remember. You say some variable name it whatever you want, equals, and then student, which is what I named the class, open parentheses, and then the arguments that the init function is expecting in. Has to be in the correct order, has to be the exact number. So I'm making John, Alec, and Rick, and if I just run this code, I can see the output right here. John is alive, Alec is alive, Rick is alive. Now let's actually play the game. So the first thing we're going to do is take John, the John object, which is an instance of a student. We're going to call fight, and we're going to pass in another object we created, Alec. So get the winner out of that. And then for whoever won, we're going to have them fight Rick. And we'll see who wins. So John versus Alec. John 1 versus Alec, and then Rick versus John, Rick 1 versus John, so Rick won all of it. Okay, so hopefully this should be recap for you guys. So, switch back to some slides here. Clicker question for you. We looked at slides very briefly yesterday, and granted it was very briefly. So, let's see what we get out of this. Converse with your neighbors. All right, a couple more seconds. The good news about stuff like this is if you ever forget it, it's super easy to Google. You just Google C++ classes. There it is. All right, let's see what we got for results here. So we got a few A's, quite a few B's, class, student, open, close parentheses, and then a lot of D's. So the difference between B and D here, as you can see, is D has a semicolon after it. It turns out you have to put a semicolon after it, which is a little bit weird. Usually scopes in C++, you do not have to put a semicolon after. For example, if you do an if statement, you don't put a semicolon after that closing bracket, but classes you do. That's just the way that they work. The answer is D, yeah. The answer is indeed D. The rest of them will just throw compiler errors. They won't do anything at all. Okay, before we get to this, let's take a look at what this code looks like, the Python code we were just looking at. See what it looks like in C++. So above, here's the Python code. This is all C++ again, this is Xcode. So we have our Python code, and let's start translating this line for line into C++. So the first thing we have to do is begin the class, which is class, student, open brackets, just like that. And I've included some things here, you can just ignore them for now. Now there's something new that Python does not have, public colon. There's also a private colon and a protected colon, and phrasing. Yes, we'll learn what those are. Don't worry about it too much for now. Now there's a function here. You'll notice something odd about this function. What did I say all functions in C++ have to do? They have to return something. What does this function return? Nothing. It doesn't declare a return type. This is a special function in C++. Just like underscore underscore init in Python was special, this is special in C++. A lot of languages have these. They're called constructors. You'll notice the name is exactly the same as the class name. It has to be identical, down to the casing. Everything has to be perfectly identical. Returns nothing, and it takes in whatever arguments you want it to take in. Yep. Yeah, right there. That's the end of class. Yep. And if I get rid of that and build, I get build failure. Voila. And Xcode knows exactly what I made my mistake at, so I just click here and it fixes it for me. So we've got this constructor. It's going to take in an std string called name. It's going to take in an int, the number of sleeps you got, I guess, and a float, how big your hangover is. And this thing's not going to do much more than the Python thing did. All it does is save the, which order I want to present this in. Forget what this is doing for just a minute. Let's scroll down and look here. This is what's different. Remember how I said Python classes don't declare much more than methods? You don't really declare data within a class. You just at runtime attach stuff to the class. And you can have some classes that have, name and then a bunch of floats attached to them, and one class of the same object type, the same class type, that's got a whole bunch of different stuff attached to it. Not so in C++. Everything that a class can ever have has to be declared up front. And it's declared within the scope of the class. So this is beginning class, this is ending class here, and this is just right within those squiggly brackets. It's not within a method, it's right there within the class. And it looks just like standard variable declarations, except you can't set them equal to stuff. All you can do is just say std string, name, capital N, and then I declared an int starting with m underscore, called it sleep, and a float hangover. The m underscore is convention. You'll see this all over the place in C++. If you've got a private member variable, and we'll go over private in a minute, You usually start with M underscore just because it's clear what's going on then. And if it's public, you usually start with an uppercase and no M underscore. So that should make a little bit more sense now what's going on up here. You've got name equals whatever was passed into me, sleep equals whatever was passed into me, hangover, same thing. And then just like in the Python code, we're just going to print out the name and then I'm alive. So let's ignore fight for just a second. If I look at the main function here, here's a few ways of how to create an object from this class. So I've got a student class, and I want to create a few instances of it, a few objects. Let's run this, see what it spits out, and we'll start walking through that code. So all three of them printed out just like we'd expect. John is alive, Alex is alive, Rick is alive.
What do you have student star?
We'll get to that. Pointers. Yeah, so these are the three different ways to instantiate a class. There are other ways, but they're much more obscure and complicated on what they're doing in the background. So there's a fundamental difference between these two lines here and the line that's highlighted in yellow, as you just pointed out. There's that student star. So let's look at the first two lines. I create a student, I call it John, and I set it equal to, and then this looks just like Python, right? Capital student, and then open parenthesis, whatever you pass into it, close parenthesis, and then the usual semicolon. This is also valid to do in C++. You can just say student Alec, and then just open the parenthesis right there. It's going to do the exact same thing. It's likely going to compile the same code. This one is fundamentally different, and we'll get into what that star is later and what this new keyword does here. But it's also constructing an object. Where it puts the object is very different than what those first two do. Fundamentally, and this is the part that makes everyone's brain melt around C++. This is the tricky part of C++. Okay, and then we've got a single method here, just like in Python, called fight. Takes in another student. This is identical code, except the C++ version of it. We're just comparing the two students using that same function. The amount of sleep they got to the power of the negative of their hangover. Of course, we can't use ampersand because, or star, because this isn't Python, so we use power F. And you guys will notice this as well. This is new too. Let's look back at the Python code, because there was something equivalent to it. And Python is the only language I've ever seen that uses this keyword. Python uses the keyword self. When you're within the code of a class, remember a class can have data in it, and it can have methods in it. When you're within the scope of a class running code, you refer to the class that you're within with the self keyword in Python. In C++ and every other language I've ever seen, the keyword is this. Python just wanted to be special. Now you'll notice that there's a star in front of this. We're going to have to ignore that for now too. That's another pointer. Yep. Are you talking about this right here? So this is just the way that you declare a function in Python. Remember that a method, when we were going over methods, I was talking about how you can think of a method as a standard function that takes in a hidden parameter, which is the object itself, an instance of the class. So in Python, for some reason, you have to explicitly declare that. Everything that's a member method, you have to declare the keyword self. I don't know why. It's really ugly. It's just like extra keystrokes that you don't need. Right, yeah, you have to declare it once at the beginning of the method. So it's self, comma, and then whatever other arguments you want to pass in. And that's just Python. Like, you just have to do that for Python. It's just how they chose to write the language. You'll notice in C++, not so. There's a other student here, but right where my cursor is, right there, there's a hidden parameter, which is this, or self in Python lingo. It's in there. It's just you don't need to type it. It's the only thing that like C++ is less verbose about, which is awesome. Okay, and then if we once again just uncomment this and run it, what should get the exact same results. Alex is alive, Rick is alive, John is alive, John versus Alec, Rick versus Alec, etc. Very exciting. Exact same class. So, another question for you guys. This one we're not going to do much time on. All right, you guys all ready to jump ship? Ready? Now, how fast can everyone do it? So there's a little bit of confusion here between, we got some votes for A and C as well. So a function that returns nothing, that is what it appears to be, but that's just how it's written. It's not actually a function. This is built into the language. So it's not quite valid to say that it's just a function that returns nothing, because you can't actually have a function that returns nothing. It just looks like a function. Or a function that returns a new object. That is actually not what a constructor is. A constructor runs on an object that's already been created. So the object already exists in memory, then the constructor is allowed to go in and do whatever it wants with that object. You can think of it as creating a dummy garbage object that just has random values in it. And then the constructor can go in and actually fill that class in or object in with things that we care about. So the only valid answer is it's like Python's init method for classes. Okay, let's run over C++'s public and private real quick. You'll notice these two keywords. I've used both public here, followed by a colon, not a semicolon. Everything under the keyword public with a colon is considered public. Now the difference between public and private is if someone else is using your class, they're writing code, for example, this main here. This main is using the class. Public is what someone using your class has access to. Anything under public can be accessed by them. So if I were to say something like, what's one of the names here? msleep. If I said Rick dot, oh, let's not use Rick, it's special. msleep equals 4. And try to build this. Build failure. msleep is a private member of student. Now, you know it's in there. You can see that msleep is in there. It's not to hide it from you. It's to make it very clear what you as a user of this class should be accessing. So you'll see that I made things like the constructor public. Constructors almost always should be public. There's a few rare cases where they shouldn't be public. So that anyone can construct a new one of these objects. If your constructor is private, only you can construct one of the objects, which can actually be useful, but we're not going to go into how. And then this method is also public. And then its convention, when you switch over to declaring data, you just redeclare the protection level. Even though it's public again, it doesn't change anything. You just redeclare it so you can just, at a glance, see this is public. And then these are the only two private things that this class has. It's got msleep and mhangover, so only a student within student code can access these two things. Yep?
So if you create a new student, can you put in your sleep and hangover or not?
Who's creating it? Are you talking about like the code right here in the constructor?
Like you said, the users can access public stuff, but then they can't accept you cannot do it.
Right.
So if someone wants to create like a new student, they could put in any name, but they can't put in the sleep and hangover.
Yes. So his question was, could they just go in and change name? The answer is yes. So it would be totally valid for me to say something like alec.name equals something else spelled minus. And if I run this, well, it won't happen until down here because that's where the line changes, but there you go. You actually change the name. Because it's public, you just reach in there and just do whatever you want with it.
Can you create a new student?
A new student from what?
Like you have John and Alec and Ray. Can you have a fourth person?
Yeah, of course. Make as many as you want. I just copy this line and then make a Sam student. As many as you want. You can also copy these things too. I could just say Sam equals Alec, and that's going to make a duplicate of Alec. Everything will be the same. Name, the int, the float, all be the exact same. Yep?
In the student file, we have, so it says that, msleep and hangover are under public, but then at the bottom,
Right. So think of it this way, rather than, so his question was, there's private under public, what's the deal with that? When does this change? Think of it instead as,
msleep is also at the top.
Oh, you're talking about the usage of it here?
Right.
So notice where msleep is being assigned. Because remember, it's private, so nobody can access it but this class. But this is code within this class. This is this class's constructor, so it's free to access all of its privates. You know, the joke is you're not allowed to touch someone else's privates. Except if you're a friend in C++, there's something called friends. And the other joke is friends are allowed to touch your privates. I'm serious, this is a real thing. Yeah?
How come Xcode isn't throwing you an error for redefining the name of sleep and name and hangover?
I didn't redefine anything, actually. This has already been defined, because remember, the constructor runs after the object is already created. So an object created in memory, it does have an msleep, it does have an mhangover, and it has a name. You can access those, you know, if they're private, you have to be the class code. But you can access those already. So this already exists, it's already been defined. And this one already exists as well. It was defined right here.
If you switch locations like lowercase name equals uppercase name, then it would say error you're redefining.
No, it won't. You're not redefining anything, you'll just be doing something kind of silly here. So what you've now set to do is set this name that was passed into me equal to my own name. But my own name is nothing. It just defaults to nothing. So you get, if I did this, you get everyone has no name to it, ironic. Is alive, one, no names here. This is the only one that has a name because it was assigned later. This guy's brain's hurting. All right, let's move on here. Next clicker question. Let's talk about some privates. All right, a couple more seconds. Yeah, I'll show you guys the results on this. Ouch. All right, let's kill this one. So we've got a big conflict here between A and B. Either for security reasons, so that we can keep things private so that they can't be hacked, or it's to help make programmers create easier to use classes, classes that are easier to understand. Let's say that someone else wrote this class, and I'm a malicious hacker. How hard is it for me to figure out what private members this class has? But I just look at the screen, we're written right there. Now it turns out in C++, you guys will see this later, when you create a class in memory, its public and private live right next to each other in memory. I can easily access the private members within the class just by doing a little bit of pointer arithmetic. It does not keep it safe in any way, shape, or form. The only thing it's used for is to make this class super easy to understand. By setting these private, I've told you guys as the user of this class, do not touch these. If you touch these, you could create just some crazy thing going on. Let me, as the programmer of this class, mess with these two variables. These are mine, don't mess with them. Now they have to be declared in the header, and you'll figure out why later. They must be declared in the header. So instead of declaring them in the header and just like putting a comment saying, please don't use these, C++ actually has this public-private thing that throws a compiler warning saying you shouldn't be doing this, this isn't good. So it's purely just a construct to make cleaner and easier to use classes. Cool, where are we? Okay, now we have to back up. Now, you'll notice, remember I was talking about header files and C++, Cpp files? Should I get through all this? You'll notice my student class here is all in a student.h. Now, C++, when it's compiling stuff, it does not know what a header is. It doesn't care about them. It doesn't compile them. The only thing that it does is pound include. That's the only thing you can do with a header, is pound include it. Now what C++ does, let's ignore the IO string for a minute. What C++ does, the only file it sees here to compile is main.cpp. That's the only CPP file. That's all C++ cares about. They're called source files. They can also have a .c extension if it's C code, CC, CXX, there's a whole bunch of other extensions, but they're all source files. They're all fundamentally the same. When C++ is first compiling, it looks through, the preprocessor looks for pound directives. This is a pound include. Now the preprocessor says, you're pound including student.h. I'm going to assume that student.h is a file. And sure enough, it finds student.h. And what it does, it takes all this text, all of it including the comments, control copies, goes over here, takes this line, control pastes. It's exactly what it does right there. So if I run this, it's going to be identical. Same thing happens. I still have my messed up constructor, so I get this weird thing. It's really stupid about it. It literally control copies, control pastes. It doesn't do anything clever. It's really, really, really dumb about it. So if you pound include multiple times, or if A pound includes B and B pound includes A, the compiler will sit there forever, just copy pasting forever in an infinite loop. It's really stupid about it. So that's what that's how headers fit into this role. So what you do traditionally, I'm going to make one more file here. Oops. What you do traditionally when you're creating a class, or any grouping of code, is you create a header. Guys, be quiet. What you guys do traditionally is you create a header and a Cpp file. The Cpp file is the only thing the compiler cares about. It's what the compiler is going to see. It's going to see main, it's going to see Cpp, all the student.cpp's, any other CPPs you have. So what you do right at the top of the CPP is pound include the header. Now this, just like before, goes to the student.h file, control copies everything in it, and pastes it right there. Now you'll see a lot of code in C++ that looks like this. It just declares that this class has a constructor. It takes in a string called name. It takes in an int called sleep, and it takes in a float called hangover. But there's no implementation. It's just got a semicolon after it. What this is called is a forward declaration. In the header, you're promising that later on, you will implement this class. But for now, this is what it looks like. You're just kind of painting a picture of what this class looks like and everything that it's going to be able to do, but you're not telling the compiler yet how to do it. This is where the Cpp file comes in. I'm going to copy paste those parameters. Okay, so this is going to get a little bit weird. You now have a header that declares somewhere I will implement this constructor. It looks like this. You now have a Cpp file that actually implements the constructor. Now you'll notice something a little bit different right here. It's got this student : : That says that this method, or in this case a constructor, belongs to the student class. This will make a little bit more sense when you look at implementing this next method in the Cpp file. So let's copy this, get rid of all this, just put a semicolon. Now let's implement this. So this function returns a student, and then it's a member of the student class, and it was called fight, capital F. It's called fight. But of course, Xcode has done this for me. Voila. So this should make a little bit more sense than the constructor. You can see this is a method. It's called fight, but it's got the student : because it's a member of student. And it's returning a student. And then just like before, it takes in a student and it does the exact same thing. So now this is what our Cpp file looks like. And this is what our .h file looks like. Yep. Yeah, very similar. You guys gone over function prototypes? No? Okay, in C++, when it reads a file to compile it, let's say you've got function A and function B, and function A needs to call function B. One way to do it is to put function B above function A. But what if they have to call each other conditionally so it's not an infinite loop? How do you do that? How do you resolve that conflict? That's called a forward declaration. It looks exactly like one of these, except not within a class. You just somewhere up at the top of the file, just put the definition of your function, followed by a semicolon. And that tells the compiler, somewhere I promise I'll implement this function, this is what it looks like. Just bear with me on this one. And then the compiler will be like, oh, okay, well, we'll just pretend like I know what it is. And it'll continue compiling until it finally actually finds the implementation. And if it doesn't find the implementation, it'll error. It'll say, you promised to implement this and you didn't. I can't do anything with this. This is just garbage code to me. So it's the exact same thing. You're forward declaring the class. So this is the entire definition of your class. The public, private, and the data members still have to be within your header. And that'll be a little bit more clear why later. But now I can do something interesting here. Within main, I can include student.h, and I can use the code. Let's clean some of this stuff up so that we get back to our old. Let's also fix that constructor. I can use this in main, run, voila, and it works just like it did before. But remember, when this pound includes student.h, all it's pound including is those 4 definitions, those 4 declarations. It doesn't actually know how to implement it. The main file doesn't. Also in C++, you can think of it this way. Cpp files are compiled, think of them as being compiled by different people. They can only kind of know about each other, but they only compile themselves. They can't reach in and look at the code of someone else. They can't look at the code of another Cpp file. So what's happening here is this class is getting pound included in the main, meaning it's promising at some point in time to implement this. And then the compiler later on sees this Cpp file, which actually implements it. And now it can fix all the problems it had. Right. Well, they get linked together. There's a separate compiler after all the Cpp files are compiled into .o files. There's another piece of the compiler called a linker. And a linker will take those separate compiled Cpp files and link them together for you. It's real magic. Yep. Thank you. I was waiting for this question. What do I gain by splitting these two? So there's a dozen different things that you gain. The biggest one is performance. If you implement all your code in .h files, compiler performance. If you implement all your code in .h files, every single time you change a single line everywhere, anywhere within any file of your program, all of it has to be recompiled. And I don't just mean your code, I mean everything you've pound included. If you pound included IO string, that's going to have to be inline, it's going to have to be linked together. So for example, the game engine that I wrote is 25,000 lines. That's tiny for a C++ program. If I do a clean compile, it takes 5 minutes to compile. Which doesn't sound like a lot, but if I have to change a single line of code and then go get a cup of coffee every time I want to see if that's valid C++ code, that's just no good. It's not something you can scale out. The other thing that you can do with it is if I want to give you guys code, I can compile all the Cpp files into what's called a library. It's a single binary file that's pre-compiled. Then I give you that binary, and all I have to give you is the headers that define what these classes look like. I don't have to give you the implementations. So I can give you these teeny tiny little headers that are really easy to read through, and then this big binary file that the compiler knows how to link against. And that's all you need. So on to that same note, what do you guys think about this? All right, a couple more seconds. 3 of you are going with E. I have 3 E's. All right, let's see what we got. Tons of D's. It's the only way the compiler can learn about other classes in different files. There are 8 people in this class who are correct. No, 8%, 7 people. Yeah. So you have headers because C++ is based on C, and C is ancient. And I mean, it's so ancient. C was designed to compile on computers that could not hold a program in memory at once. It literally could not compile a program at once. So it had to do this thing where you break the file apart into separate CPPs and headers, and then it would just compile that, and then it would save it to disk in a .o file, and then it would move on to a new CPP. And that's the best the computers of those days could do. We're talking about, like, you know, Intel 8086, 8-bit processors, C was designed to run on ancient machines. C++ is a direct subset of C, so it's the exact same. Now, you do need headers, and you do need CPPs, because C++ was set up that way, but there is no reason whatsoever that a compiler could not just read through the source file, find the definition of all your functions, cache them somewhere, and then do the exact same thing without all this header nonsense. And that's how every single modern language does it. C#, Java, all of them. You just declare all the code in one big file, and it figures out what needs to be public and what needs to be exposed and what doesn't. Computer is good at that. It can do that all day long. Unfortunately, the answer is A. Why are we learning C#? Because C++ and C mirror what's happening at the CPU level really well without getting into assembly. It's a great teaching tool. If you can figure out how to use C++ well, then you know what's going on in your computer. You can't use C++ well without knowing what's going on in the computer. It's not a very productive language, in all honesty. There's still some things you want it for, but not very many. Game engines, operating systems are still in C, actually. And C is apparently still really popular. I absolutely loathe C. But, yep, still quite popular. All right, so questions on headers before we move on. Headers, CPPs. And this is going to be really awkward for a while until you guys get used to using these. But you just got to kind of keep practicing. Yep?
Okay, so everything's running in main. Where in main does it reference student.cpp or does it not?
It doesn't. Yeah, so the only thing that it does is reference student.h. So think of these as two different people compiling code. I'm compiling main.cpp, and this person's compiling student.cpp. Let's say that I get compiled first. It turns out it doesn't matter which one gets compiled first. But let's say I, as main.cpp, get compiled first. What happens is the preprocessor goes through, it grabs everything in student.h, and it pastes it right here, like that. Now, once it's done doing all its preprocessor stuff, there's actually a whole bunch more garbage that gets dumped in from these. Once it's done doing all that, the compiler goes through, and it sees this class declaration here. So it knows of a class called student. It knows what things the class has in it, and it actually has to know about its private members. You'll find out why later. But it must know about the private members as well. That's why they have to be in the header. And it knows what constructors this has and what member functions this thing has. Now, when it gets down to compile this code, it can actually compile this. It doesn't actually need to know how to implement it. And you guys can see why that happens later. It gets into how the memory is laid out. But it does not actually need the definition to compile the line of code that I've highlighted right now. So now that it's got the forward declaration, I can finish doing what I was doing and compile, assuming that someone else will implement this. Now someone else finally gets to the student.cpp. They read it student.h, which is the forward declaration. Now they're actually going to implement the functionality. And then finally, after those two happen, there's a linker that goes through and links those two together. It's actually called a linker. Yep. Oh, these? Yeah, so in C++, there's like a dozen different parameter types you can pass into main that it'll accept. You guys may have seen something like char or something like that without the array. But there's a whole bunch of different types it'll take in. But the essence of it is you've got an integer that says how many arbs were passed into the program, and then some type of an array of strings that are the parameters themselves. And it's some variant of those. You don't. That's another one of the things it'll take in. You can just define nothing. I'm not using it, but when I create an Xcode project, that's just what it puts in for me. So yeah, there's a bunch of different things that you can define main as. You have to have a main, and it has to match one of those signatures, but you can define it as many different things. And you'll also notice I promised to return an int, but in modern C++, you do not need to return an int.
Do you define those because then you could use the function main somewhere else?
No, you don't want to call main somewhere else. There's no good pattern for that. Okay, more questions on headers and CPPs? We're actually a little low on time. I don't want to start the next section yet. So there's a couple other things to note in headers and CPPs. We'll finish off these and drive the nail in the coffin, so we're going to look at these again. One is, you'll notice in the header, the student.h, that's where I've included these IOStream, math, and strings. You don't actually need these here. because this for declaration does not need any of those. Except for string. So it still needs string. So if someone else was looking at this file, the only include they need is string to be able to read this file. Now the one who does need iostream is the CPP, because the CPP is actually doing stdcouts, and it's actually calling powf on the math library. So in here, I actually need to include those. Now that seems like a minor distinction on where to put those two, but it turns out that it's gonna cause you nightmares. I promise it's gonna cause you like all these headaches, and it's really awkward to figure out where to put your includes, either in the header or the source. And the general rule of thumb is if you can get away with putting it in the source, do not put it in the header. Which normally you don't need to put much in the source file. And we'll see how you can even get around with not including string later on and still passing around strings. There is ways to do that. All right, I'm letting you guys out early. Have a wonderful weekend. Yeah, question?